semiconductor solutions provider, and I use the word solutions very intentionally, it's very different today being in this market than it was 5 years ago or even 10 years ago. I liken it to the trend that mobile phones went through back in the 90s. If you were designing your own mobile phone in the early 90s, you probably bought a baseband processor, a DSP, a PA, a transceiver. Then you rolled your own software, you rolled your own board, you rolled your own mechanics, and then eventually you came up with your product. If you make a cell phone today, quite often you buy a chipset from a solutions provider, you buy an OS from some of the big OS manufacturers, you wrap your plastics around it, and you send it into the marketplace, and it's enabled by applications that are built by millions of people all around the world. That change in the value chain is very, very different on the mobile phone side over the last 20 or so years. The same thing is starting to happen on the base station side. As the semiconductor providers are providing more than the chip itself, it is the software. That software architecture, how you put it together and what are the requirements associated with it, is a real problem to be solved for the OEMs that build base stations, but also for the semiconductor provider. There are parts of the software that are hardware dependent. There are some that are very, very tightly coupled with your hardware, and a lot that are based on the standards of the area interface that you need to put together. Plus, you have to enable all of the application services on top. So many of these things need to be put together in a proper way to speed base station development to market. Small cells are an enormous change in how the market comes together. Today, base stations, macro base stations, are provided by and large by just a few number of companies. The vast majority of the market share is held, very tightly held, with just a few providers of the network itself. You can count them on one hand in terms of where the majority of the market share goes. Small cells, very different. There's a huge diversity of providers of small cells and a very, very different ecosystem, and that changes how the demand on the semiconductor provider comes together. It gives a lot of opportunity for everyone inside of this room and opportunities across the globe. It really means complete solutions. If I use a Freescale example, what we do is we think about the entire solution from the air to the core network, where we provide network processors, we provide the DSP and the physical layer functionality, we provide the power amplifier in our portfolio, and software that brings all of these things together. It's done with full interoperability, with integration testing, and you're really coming to the point where a reference design is practically a small cell base station as it leaves our labs and goes to our customers. But a very different mentality and quite a change in the industry in a very short period of time. The solutions that we provide and really how we design our portfolio, it needs to be air to core in terms of the thinking, but it's more than just that. It goes to some of the points that Lip-Bu and Graham were making about collaboration on a bigger level. We design our portfolio to be a complete SoC solution where it's the same architecture from a small cell to a large cell, really try to enable it with a common architecture so that software can be reused and you only have to design it once and you can scale it up and down. Put it together with a reference design and make sure that we have an ecosystem of third parties that can really take it and spin it into the diversity of products that the market really requires. But you have to build that pyramid, and that pyramid needs to be scalable across all ranges of the network. My last slide then, let's go beyond what we have today and think about the future. What are the things that we think a lot about today to enable the solutions of tomorrow? We know that bandwidth will need to increase. We know that cost will need to go down. We know that footprint needs to get smaller. We know that power consumption needs to go down. You have all of those things. You have to be able to optimize the network for latency. The more and more applications that are put on top of it, the more and more places we find network latency to be a limiting factor in terms of customer satisfaction and being able to properly use the technology for the application or the services that's running on top. The topology of the network is changing dramatically. IP traffic is going practically to the edge of the network today, and that change in how the protocols work inside of the entire network changes the topology. It also changes how the interaction between the wireless network and the data center comes together. Data centers are flattening out and also growing in size. So a huge diversity of applications and solutions need to be put together. The last megatrend that I would talk about, and I think it showed up in the previous two speakers' slides as well, is the growing importance of security in terms of how networks are put together. Security is something that needs to be considered at all places that the network is employed. It starts with the base level of the silicon that's put together. It goes to the software. It goes to the chip level solution. It goes to the system level solution, as well as the applications that make all of these devices run well together. Probably one of the largest growth industries in the world today is cybersecurity crime. Crime being a growth industry, we need a solution that's going to beat that and pull it back and make sure that the networks of the public networks, the government networks, as well as the enterprise networks are secure. And that starts with thinking about security at all levels of the processing elements. I think that is it. I know I went very fast, but important to think about all of those trends and put together the entire picture for wireless networks for tomorrow. Thank you.
Thank you very much, Mr. Tom Deitrich. I would request Mr. Guru Ganeshan, the executive committee member, to kindly come over and give a memento. The keynote address on heterogeneous network opportunity. Thank you very much, Mr. Tom, for your address. Kindly accept this memento as a token of love and affection. Thank you very much.